Hey everyone, this is a SQL challenge walkthrough. Today we're looking at week 1 of Data with Danny's 8-week SQL challenge. I'm Will. I've been a SQL user for about 8 years now. I've used SQL in many different companies across different systems. It's really helped shape and grow my career as a data analyst, so I wanted to walk you through this challenge. If you are new to SQL, jumping into this challenge may be quite taxing. You may want to give yourself a bit of a refresher. I'd recommend checking out SQL Bolt. Here we're starting with case 1 of Danny's Diner. So Danny has gone out and decided he's going to make a diner serve up sushi and ramen for his customers, and it's given us some SQL challenges to solve with that. So you get an introduction, you get all these different problems we're facing, but you also get this entity relationship diagram. And I want to spend a couple of seconds here just to talk through this. So this diagram shows you the tables we'll be working with today. So sales, members, and menu. We'll also see the different columns in these tables. So we'll see the customer ID field here, order date, product ID in our sales. Also note the data types we'll be working with varchar, which is a text field of variable characters. In this case, maximum length of 1. Other cases, date is just a normal date field. Integer will just be a numerical number, a whole number in this case. Also, we'll want to highlight these lines between the two diagrams. So this is super helpful for telling you how you can join these different tables together. So here I know that the customer ID here in sales matches to the customer ID here in members. Similarly, product ID here matches to product ID here in menu. So I want to bring your attention to these lines around here. So this line here with a single slash going through it indicates that this product ID is unique for the menu table. And these 3 lines here indicate that the product ID may appear multiple times in this table, in the sales table, which makes sense. So our menu is going to give us a list of individual products and their prices and their names. Those products may be sold multiple times. And here are a list of case study questions. So 10 questions to answer with a couple of bonus sections as well at the end. For this challenge, I've loaded all the data into Snowflake. You don't have to do this. This should work perfectly fine using this SQL query tool here. Okay, so starting off with question 1. What is the total amount each customer spent at the restaurant? So if I refer back to my diagram, I'm going to need to know the sales for each customer and then also the price here for menu. So I'm going to need to make this join. And by looking at this diagram, I can join on the product ID here. So let's do that. So if I do select start from sales, I can see this customer sales data come through here and that product ID. So what I want to do is I want to do an inner join on the menu. So if I do menu, what I need to do here is give these aliases to make the join less wordy in this case. So if I do join on sales dot product ID equals m dot product ID, and then if I run that, you will see that I've got these extra columns come in, so I now know my product names and the prices. So to find the total amount for each customer, I need to go customer ID from our sales table and then the price. So I've got those 2 columns. So if I want to know the totals, I would do an aggregation. So I will sum price, give this as an alias as total spend, group by customer ID. Otherwise SQL is going to throw an error. Okay, so there I go. I've got the total spend for each customer. Okay. Question 2. How many days has each customer visited the restaurant? So if I dive back into sales, so I'm going to aggregate again. So in this case, I'm going to do my customer ID. So for this, I'm going to use my customer ID. I'm then also going to use my order date. and I'm going to need to aggregate this to count those days. So what I would do is I would do a of the distinct days, order dates. I'm using distinct here because, say, on this day the customer's ordered 2 products. I want to just know the individual days, so I use distinct just to count the distinct number of those, the unique dates. Call that adds days. And then group by that customer ID, otherwise SQL is going to throw an error. Okay, so there's my days for each customer visiting the restaurant. So on to question 3. Now, the wording here is not great, so there's a bit of ambiguity with it, so I'll say there's 2 types of solution for this, but let's dive into this. So what was the first item from the menu purchased by each customer? So we're going to want to know the time, we want to know our customers, we want to know the time they purchased that, and then we want to know those menu items as well. So if I pull my data from sales, I've got my customer ID and I've got my order dates here. I now need to go and find what those products are. So again, as we've done earlier, I can just do my inner join back to menu. Let's go inner join to menu. That's S for sales. Okay, so I've got all my columns coming back. I just need to reduce this down a little bit. So I've got my customer ID, got my order dates, and I've got my product names. Okay, to do this, you can sort of notice some issue we're going to have with this. For like customer A here, they ordered sushi and curry on the 1st of January. I don't know which one they ordered first. You can't rely on SQL to return you the order, which return you the correct order that entries have been put in. So we're going to need, this is where the ambiguity comes in. You can return, I say you can return both of these or you can return just one of these. To find out which was the first product, we're going to use some functionality called rank and row number. If I do rank, strange quite functionality, so you have rank and then you've got to say what it is ranked over. So rank over and then partition by. So how do you want to split the rank? In this case, we can start counting between our different customers. Customer ID. And then you've got to order it by something. So rank needs something to sort on. So I'm going to order this by order date. And that will be by default ascending, or I can do ASC to say that is ascending. I'm going to give this an alias as rank. Okay. Oh, and I've got a syntax error. So if I change this partition by, yeah, that works. Okay, so you can see here how rank is working. You give rank 1 for this, rank 3 for the next item. Okay, so I can find my first order, in this case, my first orders. Okay, similarly, that partition is working here for B. So I can see here that when it gets to B, customer B just restarts again from 1. Okay. Alternatively, you could use row number, which has very similar functionality, but you'll see the difference. Okay, so here it is with row number. You can see it just does just a countdown of what there is here. So before we had customer A, we had sushi and curry were both 1 in the rank mode, but now they're 1 and 2. We've just picked that sushi's going to be first on the list. So this is where the ambiguity comes in. I'm happy either to do one or the other. I'm not too fussed in this case. But how am we going to get this filtering? So if I try and do, say, a where clause on this rank, so if I want to find whether rank equals 1, SQL is going to throw an error. And this error is saying that basically rank is a window function. It needs to have everything there so it can calculate the rank. So it can't be used in this where clause. So a way we can get around this is by using something called a common table expression, or CTE, you might have seen. So if I do The notation is a little different, but essentially what you're doing is writing a query that you can reference later on in another another query, like or another select. Okay, so I've rewritten the previous query. I put it in this common table expression, CTE here, with this notation with CTE as bracket, and then select star from CTE. So if we run this, we'll get our results back. So as we were before, but now we can query these columns, these windowing functions we were using earlier. So I can say select star from CTE where, say, rank equals 1. Okay, so I can bring back those first orders for those customers. Again, you can do row number. I'm not too fussed for this. I feel that either one is acceptable. So we can just clean this up a little bit. So I'm going to go and have customer ID. So there we go. So we've got this idea that customer one did product name is sushi or curry or ramen. If you did row number, here's the solution. This may differ depending on how row numbers kept sorting things in your SQL, so this won't be exact each time. Okay, question 4. What was the most purchased item on the menu and how many times was it purchased by all customers? So I think we can start again with sales. So select star from sales. I'm going to want to do that join to the menu to find out the product names. So if I go and take what I've done earlier, inner join menu, and then as so we're joining my menu via the product ID. Okay, all my columns come back. So to find the most purchased item on the menu, I want to do my product name and do just a count, just a normal count of the different orders. Call this orders. I'm also going to need to aggregate this, otherwise SQL is going to throw an error. Okay, so I've got this list. I can now order this by my count order date. And I want to do this descending, so DSC. Okay, now I just want to return that top item. So I'm going to go limit 1, as in limit the results just to 1. Alternatively, you could do select top select top 1. Give that a run, and that will give you back the same. So top or limit will work here to reduce the number down to 1. Result. Okay, question 5. Which was the most popular item for each customer? So we're going to work with a lot of what we've done earlier. So we found that top products by orders. I can take what I've done before. What I'm going to do is going to add in customer ID here and then group by customer ID. Drop this onto a new line. So run this. So okay, so now I can work out all the different products that were ordered by those customers. So for example, I know that for customer A, ramen was their most ordered item. Again, we're going to have ties here. So customer B split between all three and customer C was just ramen. Okay, so we've got all my orders for my different products by my different customers. I'm going to use what we used earlier, rank and row number again, to find out this top product. Ooh, not that one. So if I take what we've done earlier, change this a little bit. So rank over partition by customer ID is fine. And I want to order it not by the order date now, I want to do it by this count. So I want my count of order date descending. There's rank. I'll give that a run. Okay, so now we have this rank coming through here. Again, you may want to do the same but with row number. So again, you can see what we're going to do here is rank or row number equals 1. As last time, I'm going to put this into a CTE with CTE as bracket where rank equals 1. So again, we're going to use rank in this case. You can use row number if you want to get down to one answer. In this case, I can't split these ties between carry for customer B, so I'm just going to keep all of them in that they're group tied. And we're just going to tidy this up a little bit. Okay, so I'm just going to return that. So just customer ID and the product name for those ranks. Again, row number. If you're doing row number, this is your answer. Okay. Again, that answer may differ based on the ties you have for customer B. So I'm going to stick it with rank for now. Okay, question 6. So which item was purchased first by the customer after they became a member? If we recall, so we've been doing a lot of sales to menu, back and forth here. Now we're going to go into members here, this members table, to find this customer join date. So I can see here, I'm going to need customer ID to customer ID in this case. So I'm going to want to do that join to my members table. So do inner join members as mem on mem dot customer ID equals s dot customer ID. Okay, so if I run that, okay, so I get my customers coming back from sales, and then I've also got that join date coming through too. So I can reduce this down a little bit. So I do my alias for my customer ID, so s dot customer ID, and then I'm going to find my order date, my product ID, and my join date. Okay, I'm also going to need to know what those product IDs are, so I'm going to join to menu again. Again, I'm just going to copy and paste what I've done earlier for inner join to menu. And then here I'm going to bring in that product name and get rid of product ID here in this case. So if I want to know which item was purchased first by the customer after they became a member, I'm going to need to use a where clause and say where my order date is greater than or equal to my join date. Okay, so that's filtered those results for me. I can now then also have row number or rank again to order those. So I take my rank from earlier on rank over partition by for each customer, order by the order date. Order date ascending, you don't need to put ASC, it's done by default, so I'm going to leave it for now. And then we'll do the same for row number and see if there's any difference. Row number. Okay, so ambiguous column name, customer ID. This is because customer ID appears in members as well as sales. So what I need to do is give this that alias. So I did this here first off with s dot. So I'll do this again. S dot customer ID, s dot customer ID. Rerun this. Should work. Okay, scanning results. It looks like rank and row number are the same in this case, which is nice. Again, I can't put rank or row number in that where clause because it's the window function, so I'm going to use just a little CTE to put that in. So I can query this after it's calculated that window function as CTE as that. Select star from CTE. Tidy this up a little bit. So I've queried my common table expression. I've now got those columns coming back. I'm just going to say where rank equals 1. Okay, and then tidy this up a little bit. So customer ID and name. Okay, so those are my products. Those were first ordered after they became a member. Note customer 3 isn't a member, so won't appear in this table. Question 7, which item was purchased just before the customer became a member? Okay, so this is going to be very similar to the last question. I'm just going to take what I've done earlier, copy and paste this, and then I'm going to reverse this. So where the order date is less than the join date, so before they became a member, note that customer C won't appear again because they're not a member at all. So I can just check this is working. I'm just going to comment out this and just do select star from my CTE. Okay, yeah, it's trying to run both queries. So if I put a semicolon there, that will work. That will separate those two. Run that. Okay, yeah. So have I got the, yeah, this is the question. Have I got the ranking right? Okay, so we now need to rank descending rather than ascending in this case. So change these to descending, order date descending, date descending. Again, see what comes back here. So again, we have some ambiguity where for customer A, they ordered two things on the first order on the same date, so we can't separate those unless you use row number, but it may not be the correct answer. So we're going to use rank again. Okay, so I can go tie this up, put rank equal to 1, and do customer ID. Okay, those come through. Okay, what is the total items and amount spent for each customer before they became a member? Okay, so we can use what we've done earlier in this case. So in question 7, we worked out this, so I can bring this in as a starting point. So I can get rid of rank and row number. That's fine. So if I go and select run this. Okay, so we know the different products that they ordered, total items and amount spent. So I can also bring in the price in this case. Okay, now I should just be able to do an aggregation on these. So if I want to know total items, I could count that product name and give an alias total items. Similarly with price, I can sum that and call that as amount spent. Now because I'm aggregating, I'm going to need to put these other columns. I'm not going to need these. So I'm not going to need to know my join dates and my order date because that criteria of ordering before they joined is already done by this where clause. So I can get rid of these two. So really I need my customer ID, so I can group by customer ID. So we can now see these customers before they joined. These are the total items they purchased and the amount they spent. Okay, question 9. If $1 spent equates to 10 points and sushi is 2 times points, how many points does each customer have? Okay, so what I recommend for this is to select star from menu. If I select star from menu, we can start working out this points function. Okay, for this, I'm going to want to use a case expression. So I do case when product name equals sushi, then is going to be the price. Normally it would be times by 10, but because it's sushi, we're going to times by 2 as well. And otherwise, the price is going to be times 10. Okay, and then I'm going to end and call this points. Okay, you can see how this is working now. So sushi's coming back as double. The case expression here is sort of like if this then that, as if else sort of statements if you used other programming languages before. So when sushi is this, when this condition is met, then do this, else otherwise do this. It's super helpful in this case. So I now basically evolved the menu tables now include these prices. So I can now go and join this back to sales. So I call this as M, and I go inner join. Go inner join sales. Yes. Okay, so if I go and just tidy this up, so I go and change this to customer ID. Go and bring in product name just for some checks. Okay, so I can see for customer ID these points are coming through as they were in the menu. So I can, if I'm going to calculate the total, I'm just going to go and aggregate this. So I go and do my sum of my points. So I put a sum around that case statement. I can get rid of product name here. And because I'm aggregating, I'm going to put any other columns, in this case customer ID, in my group by. Okay, so those are the points for each customer. Okay, so this is where it escalates a little bit. So in question 10, in the first week after a customer joins the program, including their join date, they earn 2 times points in all items, not just sushi. How many points did customer A and B have at the end of January? So if I start from what we did previously, if I go and take this, so I've got my menu, I've got my sales table. I'm going to remove the aggregate, otherwise that's just going to cause some extra complications for this stage. If I go and do an inner join on members, I will change this to s dot, otherwise SQL's going to ask which customer I'm talking about. Go and add m dot star here. So I want to return all columns from the members table. So I've got the customer ID and I've got that join date here. What would be helpful is I had s dot order date and change that to join date. Okay, yeah, common one. Forgot a comma there. For this order, is this customer in the actual membership? In this case, no, but I know this will be membership start as a date, and then it'll be a week later. So what I can do is use the date function, so I can do date add, and then you can see here Snowflake's telling me which ones it wants me to do. Date time function I want to add. So is it days, is it weeks, is it months? How many of those days, weeks, months? And then what I want to add it to. Yeah, that seems right. So it starts on that date, and that will be the last date. Okay, so I know if they ordered anything between these dates, then they should get double points. So I can update my case statement here saying when order date between this date and this date, then return the price and return it times 2. So it's on everything, not just sushi. So just need to double check that's working. So an easy way to do this would be, say, go move this again, change this to all points, Get rid of this line I've added. Okay, so you can see in the old system that customer A currently got 150 points on the 7th, but the offer started, they became a member on that day, so they get double points. Okay, so I'm happy that's working. Okay, so get rid of this. I can get rid of these two. Yeah, I can get rid of all of this. Okay, so I've got this for all of these different orders of all time. I want to know how many points they have at the end of January. So I'm going to use a filter over where. So what I can use is a function called date trunk, which will change the date to the first of that month. So date trunk, I want to do month of my order date. And what we can do, so I can see what the values are coming back. So if I bring this, get rid of that there, I can bring this in here to see what this is doing. So my date trunk, okay, so it's coming back as mentioned, so 1st of January 2020, so return just the month. So we'll exclude this value here. So I can go and set date trunk, double check. Yep, those are all coming back for January. I can get rid of this. And now I can do that aggregation we had earlier. So I can go and sum these different points and then group by, give that a run. Okay, so those are my different points for my customers in January based on this new program. Okay, for this bonus section, I've been asked, hey, can you go and recreate this table for me? So my customer IDs, my order dates, product name, the price, and whether they're a member or not. As we can see here, we also notice that customer A isn't a member to start with and then becomes a member later on. Okay, so we've got to be wary for that. So I start as usual with select staff from sales. So I've got my customer ID, I've got my order date done. Customer ID, got my order date. So for this, I'm going to need to know my product name and my prices, which I can get from the menu table. Okay, so I can see I've got my customer ID, order date, product name, prices. So I just now need to go and work out what this members is going to be. So if I go and left join, bring me back those columns for members. Oh, okay, yep. So ambiguous column again because I've got customer ID twice from different tables. So I put an S there. So you can do a case statement. When we'll also have the criteria here that the date may also be null. So I can say also when. Okay, so we've got that coming back. So we're looking pretty close to the outcome, what we want. So all I need to do now is just go and order this. So I need to order it by the customer ID, order date, and it looks like price descending. Yeah, okay. So I can do that here. Order by customer ID, ordered ID, and then price descending. Okay, that looks pretty good to me. Okay, last question. So rank all the things. So here, what Danny's asking is that can we provide some kind of ranking on the orders of these different items if they're members only. So if they're not a member, you want null. Otherwise, you want to rank these items in the order they were ordered. Also tying if it's the same item on the same date. Okay, so we can take what we've done in the first part and then start adding this rank to it. So as earlier, I can add in this rank over over this partition by, so it wants to be by the customer ID, the order, yeah, by the customer ID, and then we want to order by the order date as rank. We'll just run this. I know there was more we had to do on ambiguous customer. So s dot customer ID. Okay, so we've got this rank coming through. Now we just need this criteria that before they were a member. So I can use what I've done earlier in the case expression again, just so when this condition was no for member, I can just put rank to this column to null. So case when else rank, and then end as rank. So let's take a look what this does. Okay, so it's doing it's doing the ranking, but it is skipping these first ones. Okay, so I want it to work when it's on the actual member itself. So one way to get this ranking to work, I can just go and say, oh, it needs to be partitioned by this member column here. I can't call that member column, so but I can call the case statement that makes it. So I could go and partition by the customer ID and then just bracket, put this case expression in there. If I run that, that works, but the code itself looks horrible or messy. So just to make things a little bit neater, easier for someone to understand, I'm going to put this in a common table expression. So I've got that there, so I can now go and bring in that ranking that we had earlier. Now I can partition by member in this case as well. Okay, so I'm going to need to change up my case statement a little bit, so we can change this so when member is no, capital N, then no. Okay, and yeah, need to remove that alias because it doesn't not required anymore. Okay, so there's my rank now coming back as well. The solution looks pretty good to me. I'm happy with that. We've done quite well. So we've gone through and completed this challenge. I'm going to go and copy all of this code. I'm going to save it to my GitHub account. I'll share you a link to that in the description below. Other than that, I hope you had a good time solving this challenge, understanding these different problems and how we can solve them with SQL. I'll catch you in the next one. Bye.